Welcome to KA Continued. Previously on AP Chem, we talked about weak acids and dissociating weak acids and their Ka, their equilibrium constant. And the general term for weak acids, we just use Ha, we just used Ha to kind of make it easier in case we get some weird acids on the AP exam. So we have our acid dissociation constant, Ka, equals our concentration of our conjugate base times our concentration of hydronium ions all over our concentration of our weak acid. To add to some of this, just FYI, the weaker the acid, so the weaker the weak acid, a few things happen. We get less dissociation. Our hydronium ion concentration is lower, and the pH is higher. So take a moment to ponder that our hydronium ion concentration is lower. That should make sense that if that's true, our pH is higher, but it's still less than 7 because we're talking about acids. So take a moment, ponder those thoughts. Okay, let's just jump right in and determine some Ka experimentally. So we have a 0.1 molar formic acid solution. Formic acid is ant venom, so that's really exciting. You can think about that when you see ants crawling around. And it should look, the formula should look familiar, sort of, to CHACU or acetic acid or acetate, because this also is a carboxylic acid, just like acetic acid. Acetic acid is also known as ethanoic acid. This is known as methanoic acid. So if you remember some of your organic stuff, I'll just give you that little information before we get started with this to tie it into what we've been doing. So 0.1 molar solution gives a pH of 2.4. Find the Ka. Well, just like any good chemistry student knows, the first thing you need to do is start with a balanced equation. So let's get a balanced equation written. And hopefully that's what you came up with for your balanced equation. Now, what information do we know? We know the pH is 2.4. We also know we have a 0.1 molar solution of the acid. So we're going to have to be doing an ice chart here because we have initial and we have changes, but we don't know what it is at equilibrium. And remember, Ka is an equilibrium constant. So go through, figure out all the information you know, and put it into an ice chart. So take a moment, pause the video, and try it on your own. Seeing as we have an initial concentration of 0.1, and we have a pH of 2.4. So that tells us a little bit about our hydronium, or our change in hydronium ion concentrations. So try that out, come back, and we'll see how you did. Okay, how'd you do? I hear screaming. It's okay. Where did I get the 0.00398 from? Okay, we're going to go back to stuff we talked about a few days ago, or yesterday. And our pH of 2.4, we can use that to calculate our hydronium ion concentration. So remember, pH is the negative log of our hydronium ion concentration. And since we're given pH, hydronium ion concentration is the anti-log. I don't think I use that word ever, but this is how it works. It's 10 to the negative 2.4, and on your handy-dandy calculators, if you find your log button, you'll see a 10, hopefully a 10 to the X key, although some of you have really crazy calculators, so you're going to need to figure out how to do anti-logs on your calculator. But that's how you go back and figure out the hydronium ion concentration. So we got that, and that's our change. So as it reacted, it produced hydronium ion concentration. Hopefully some of you right now are wondering why I put approximately 0 for our initial hydronium ion concentration. So what's up with this? Well, part of that is because of this. So this is in water, and water self-ionizes. We've talked about that. So really, we always have hydronium ion concentrations, and it's around 10 to the negative 7th in any solution. That's why I put approximately 0, because it's not actually nothing. It's 10 to the negative 7th. But really, with that many decimal places, we can assume it's almost 0. So that's just some more information for you. Also, some stuff for you to ponder and think about. Notice our sig figs. Wow, we haven't talked about those in forever. But notice our concentration only goes out here to the thousands place. So really, this 0.00, this 0.98 is not going to make a difference. So for equilibrium, just to make calculations slightly easier, we're going to call this, we're going to round that 0.003 to 0.004. And we're going to call at equilibrium, we have 0.096 molar here. And then these will just bring down as is, which is fine. Or we could call it 0.04. But since we're adding it to 0, we're just going to call it 398, and life will be good. Okay, now we can use all of this and plug it into our Ka expression for this equation. Now you can go back and kind of cheat and use the HA, so on and so forth, but let's actually use the Ka expression. So this is our Ka expression for the actual equation we used. Like I said, for ease, if you want to cheat and just use A minus and H3O plus, and that's cool. So we're just going to plug numbers in and get our answer. So this is, once you get to this point, life is pretty easy. So our point 00398, I'm going to say it's squared because that's the same number for both of those. And then over our concentration at equilibrium, 0.096. We calculate that and we get 1.65 times 10 to the negative 4th. That should make some pretty good sense for this. The next thing we could do with this problem is figure out our percent dissociation. So how much did it actually break apart? I may save that for class so as not to hurt your heads too much while we're not together. Although if we're not together tomorrow, that's what you can expect. So you should be able to calculate Ka given a pH. So for practice, on page 655 in your book, try number 16.43. The answer's in the back of your book, so you can see if you understand this. Okay, that should do it for the snow day. We have a lot more to cover. I may be making some more videos while I'm here, and you can watch those at your leisure. But this is the only thing that I'll quiz you on tomorrow, so I'm thinking probably only 2 questions, very similar to this, to find the Ka given the pH of a weak acid solution. So that's what we have. Enjoy your snow day and keep checking on Schoology, because who knows what's going to happen in the next 6 hours while I'm tooling around here. All right, take care. See you guys tomorrow.